To understand a bit about the history of the x86 chip to be able to understand why floating point is done the way it is. The original 8086 processor did not include floating point. Floating point calculations were done in the software by a collection of routines that emulated a floating point processor. Then the 8087 processor was added as a coprocessor to perform floating point operations. It may or may not have been installed, so software was written to use the processor if it was present, or use the library if not. Things stayed this way for a while. The 802.86 and the 803.86 both did floating point using math coprocessors that may or may not have been present in the machine. The presence of the math coprocessor would cause some software to run faster because operations were being emulated with integers in software. Now, however, the floating point coprocessor is gone, and all floating point is done in the same chip. However, remaining consistent with earlier architecture, the floating point operations are entirely separate from the integer operations. Floating point has its own set of registers, and these registers have an entirely different organization than the others. There are 8 of them. They are named ST0 through ST7. They're named ST because they work like a stack. Floating point operations work with ST0, the top of the stack. All new numbers are added to ST0, the register on top of the stack. Numbers already in the registers are pushed down on the stack. Also, numbers can be popped off the stack from the ST0 register. All floating point operations involve the top of this stack. The floating point process has its own flag register or condition codes, status codes. These are completely separate from the flags you've seen so far. You can't even branch according to these flags, but you can copy the flags, so there are some things that you can do, and I'll be showing you how that works.